Back to the last part of our law of signs. Today we are going to talk about the ambiguous case that happens when we have a side-side angle given situation. Now, what does the word ambiguous mean? Well, the word ambiguous means that there is more than one meaning slash an unclear answer. So why do we call this the ambiguous case in this particular situation? Well, this is going to happen again when we have a side angle given situation. So we would ordinarily use law of signs to help us find another angle. However, there might be no triangles possible, one triangle possible, or possibly even two potential triangles. So again, this is going to happen a no triangle situation when your two angles that you find, the one that you're given and the one that you find, sum up to be greater than 180 degrees. And this is a problem because we know there are only 180 degrees total. If we're already over that limit with two of the angles, there isn't going to be a third one. You might also see this as you are going to calculate, you get an error message in the calculator basically saying that this cannot be computed, these don't make sense. So if you get that error message, that also is going to be a no triangle situation. One triangle is when we can just, only have enough 8 degrees for one triangle, our normal situation. Two triangles is going to happen that after we solve and form at least one triangle, a second triangle is possible using the supplement of our found angle. So we'll see how that works out on there. Okay. So again, you're basically going to go through and complete the problem like you normally would. You would use your law of signs. This is again only going to happen when it's a side-side angle situation. And again, you want to make sure that there are only 180 degrees even in your first triangle to make sure that that's formed. If the second triangle is possible, it's due to an isosceles triangle being formed where this hinge kind of happens, and a second layer is the supplement angle is basically going to end up being small enough so that a second triangle has 3 angles possible. And again, you find the supplement by doing 180 minus that angle. And again, you're just going to test out, is there enough space in both of these? So you'll see why this works out is because, again, your given info is not basically clear. That's the ambiguous part on if it's just this size triangle or if you could swing that and make it larger to have that. So we have a kind of pictures to accompany each of these. You have the 2 triangle one and a situation where that might happen versus just a 1 triangle where this is already too big if we tried to look at that supplement, so it didn't work out. All right, so again, to start these off, we are just going to, like our normal triangles, look to find our given info. So we're going to start, we need a little picture would be nice here. So we have angle A is 20, B we don't know, and then C we don't know, but we know little c is 11, little a is 8. So again, we know we have a side and the angle across from it, so we would have 8 over the sine of 20. And we can then solve for angle C because we have the side across from that, and we can look for angle C. So when we cross multiply and solve, we end up taking 11 times the sine of 20, and then we also know that if we divide over that 8, sine of C would end up by itself, right? So we have then sine of C equal to this. So we know that if we sine inverse, we would actually get that angle measure. So 11 times the sine of 20, and then make sure we close that parentheses, divide by 8. We end up with about 28.1 as our potential angle C. Now this is small enough, right? If we took 180 minus 20 minus the 28.1, there's more than enough room left over for angle B to exist, the 139. So we know there's at least one triangle. Okay. Now the second triangle that would exist would have the exact same given info, right? That this is 20, this is 11, this is 8. The key here is that this new angle C would be the supplement of the one we just found. So 180 minus 28.1 would give us an angle of 151.9. Well, 151.9 is the other possible angle. And again, if we try to figure out, okay, is this going to be small enough so that if we look for angle B, will it exist too? We find that this is small enough that angle B would also exist, and both triangles would have small enough angles that they all exist. So we would say that this is a two triangles possible situation. In our second example, okay, we are again given as a given angle, little a this time is 20. We are looking for C. This time as we go to start solving, we can take our given angle inside, so 20 over the sine of 15 degrees is going to equal 16 over the sine of C. So again, we know we can cross multiply and solve. 16 times the sine of 15 degrees, all divided by 20 is what the sine is equaling. To get that angle, then, we are going to take sine inverse in order to calculate that. So 16 times the sine of 15 degrees, all divided by 20, we get about 11.9 as our degrees here. Now on this one, if we subtract from 180, the given angle and our newly found angle, we find that we are good, that there is going to be at least this triangle formed, because our missing angle B up here would be 153.9, and we are good to go. Now, if we try to draw a second triangle with, again, the exact same given info, except that the angle C is now the supplement of 11.9, so 180 minus that, then we're going to see, like, oh, wait, 168, that's way too big, that if I took 168.1, there's not enough degrees left over using the given, and now 168.1, we're into the negative degrees. Like, that's not enough room left over. That's negative for angle B to exist. So if de facto, that second triangle just is not going to exist. So there's only one triangle this time. All right, on our next example, we are given this time that angle A is 139 degrees, little a is 9, and then C is going to be, little c is going to be 12. So again, if we start trying to solve on this one, we have A and sine of A equals 12 over the sine of C. Cross multiply and solve. 12 times sine of 139, all divided by 9. And we need angle C, so we need the inverse of that. So this time we have sine inverse of 12 times sine 139, and then that value divided by 9. We end up with 61 degrees for angle C. Now what we're going to notice on this one is if we try to subtract and figure out what angle B is, again, similar to that last example, we actually find out this is too big, right? 139 degrees and 61 degrees, they're taking up more than 180 of the degrees, so angle B would not exist, and there would not be a triangle possible at all on that one. All right, and then we have letter C for you to try on your own. All right, now oftentimes what they are going to want us to do is to determine how many triangles do we have and then fully solve them out as needed. So if we start off just like we have been doing, we want to look for A, B, C, fill in our picture. This time I'm giving angle B and little b, and then I'm given little a. So actually the side angle I'm solving for to start on this one is going to be angle A, because I have 32, which is across from that. And then I have given to me 30, and its angle buddy 50. And if we cross multiply to solve, and take the inverse, we end up with 32 times sine of 50, and then divide that 30 over to get the angle A by itself after we inverse. So sine inverse 32 times the sine of 50, all divided by 30, we end up with 54.8 degrees. So that's angle A, and we know that 180 minus 54.8 minus the given angle of 50 is 75.2, so there is at least one triangle that's going to exist here. Now the second triangle, if it does exist, is going to have the exact same given info. However, the only difference is that instead of angle A equaling 54.8, it would need to equal the supplement of 54.8, which is 125.2. Now this is still small enough if we take 180 minus the supplement minus the given angle that we can't change, the 50 degrees. It's tiny, but angle C is going to exist on this one. It would be about 4.8 degrees. So this is in fact a two triangles situation. Now our first triangle, we already started solving, right? A, B, C, we found that in this first triangle, we had some given info that wasn't gonna change, the given angle of 50, 32, and 30. We then found these two angles already, 54.8 and 75.2. Okay, really all that is left for me to find then is side little c across from my 75.2 angle. And again, I'm going to choose to use the given side of 30 over its sine of 50, cross multiply and solve. This time we are looking for a side, so no inverse required. 30 times the sine of 75.2. Close that parentheses and then divide over the sine of 50. We end up with 37.9 as our missing side here. And then on my second triangle, again, when we started looking for the triangles, we actually solved most of this, right? We still have that given info that's not changing. And then we had to find in this one that this supplemental angle was 125.2. This was 4.8. So that's 2 out of the 3 things we need. We have all 3 angles, and now we just need to, again, find this last missing side. This time my side is across from the 4.8 degree angle. I can use 30 and the sine of 50 since those were given to me. I have 30 times sine of 4.8. And then I'm going to divide that by the sine of 50 to get c by itself. I end up with 3.3 as my value of my missing side. So the nice thing is by finding out how many triangles there even are, we kind of end up being able to solve for all the missing sides and missing angles because half of our work was completed just in the decision making. Thanks everyone for watching. We will work more with these in class.